Let's do some more complex fractions. Here's an example. Simplify 1 over x minus 1 over y. We're dividing the whole thing by 1 over x plus 1 over y. If I tell you to simplify, there's actually two ways to do this. We'll talk about the other way in a different video. But I want to point out one thing first. A lot of students want to cancel this. Maybe cancel the 1 over x's and cancel the 1 over y's. You cannot do that. You cannot cancel because you have addition and subtraction. If you had 1 over x times 1 over y times 1 over x times 1 over y, then yes, you could cancel those. If there's multiplication in here, here we have addition and subtraction. So don't do it. Okay. So now that we've cleared that up, how do you do this? So one way is to build a common denominator. Okay, so I'm going to rewrite my vinculum. That's what this is called. This is called your vinculum. Okay, and I'm going to focus on the numerator of my fraction now. Okay, so I have 1 over x and 1 over y, and there's a minus in the middle. I would like to build a common denominator. So I want the least common multiple of the denominators. Okay, so well, there's not anything very interesting. On the first one, there's just an x. So I'm going to write down the x. And I look at the second denominator, and there's a y. No factors in common, so I'm going to need both of them. So remember, if you have an expression, there are two things I'm allowed to do. If I have an expression, I can multiply by the number 1. Now it's going to be a fancy number 1 sometimes, but I'm allowed to multiply by the number 1. So I'm allowed to multiply this by 1. But in math, that would be too easy. We want to do something really fun. So there's another way to write the number 1. I can write the number 1 by putting something over itself, right? So I need this to be the denominators, right, of that numerator. If I get that to be the denominator of the numerator, then I can combine them, right? So this piece is missing a y. But if I multiply the bottom by y, I have to multiply the top by y. That way I'm multiplying by the number 1. Do you see that? So 1 over x, this is really times 1. So I have not changed it mathematically. So 1 over x times y over y is still 1 over x. And the reason I chose to do that is I need another term on the denominator. I had an x already. I need the least common multiple, the common denominator, to be x times y. So I had to multiply by a y. I'm going to do the same thing here. Multiply by a fancy number 1. The reason I need a number 1 is I need my denominator to also have an x in it. If I multiply the bottom by x, I better multiply the top by x. We see that x over x is 1. So 1 over y times x over x is mathematically equivalent to 1 over y. Now, I look at these, and you see that I have x times y and y times x. We know by the commutative property, x times y is the same as y times x by the commutative property. So it looks like I have it. So let's do the same thing in the denominator. We had 1 over x plus 1 over y. We're going to do the same thing. We're going to build a common denominator. Turns out the least common multiple of the denominators here is the same as in the numerator. So it's going to be x times y. So this piece is missing a y. I put a y on bottom, better multiply by y on top. That way I'm multiplying by the number 1. Because I'm only allowed to multiply an expression by the number 1. I can also add 0, but that won't help us here. But I'm allowed to multiply by 1, which means the top and bottom have to be the same, the numerator and denominator. So I have 1 over y as my second term in this denominator. I need the denominator to be x times y. So that means I have to multiply by x in the denominator, which means I have to multiply by x in the numerator. That way I'm multiplying by the number 1. Okay, so we get y over x times y minus x over yx. I'll fix it in a second. And the denominator is y over xy plus x over yx. And we said earlier that xy and yx were the same thing. So I have y over xy minus x over xy. And I have y over xy plus x over xy. And we have this super fun rule that says if you have a over c plus b over c, if they have the same denominator, a common denominator, you rewrite the denominator and combine the numerators. If you notice, these denominators are the same. So I can rewrite that denominator, xy, and combine the numerators. Does that make sense for the numerator of my fraction? These are the same thing. Let me show you. This was the y here, my minus sign, and here's the x. I just wrote them all in one piece. Okay, we're going to do the same thing with this denominator down here. They both have an xy as the common denominator, so I'm going to combine the numerators. And now we have a fraction divided by a fraction. So that's the same thing as rewriting the numerator and then multiplying by the reciprocal of the fraction in the denominator. So here's my numerator, here's the denominator. So I'm going to rewrite the fraction that's in the numerator, y minus x over xy, and I'm going to multiply by the reciprocal. I need the reciprocal of this. Reciprocal of a fraction just means we flip it. If whatever is in the numerator becomes the denominator, and whatever is in the denominator becomes the numerator. So I get xy over y plus x. And we see we have an x in the numerator, an x in the denominator, a y in the numerator, a y in the denominator. We can cancel those. So let's look at what we have left. We have a y minus x and a y plus x. Do not cancel those. You are done. You stop. Let's try another one. Simplify 7a divided by a plus 1 over a. So this is still what we call a complex fraction because there's fractions mixed in within fractions. Okay, so we're going to do the same process we did on the previous example. We're going to build a common denominator on the piece that has the multiple fractions. So notice here my numerator is pretty easy, just a 7a. I'm going to rewrite that. So that's 7a. But down here I have an a plus 1 over a. That doesn't look like a fraction plus a fraction, so I'm going to write that as a over 1. So now I'm going to build a common denominator. So I'm looking for the least common multiple of the denominators. So 1 and a. Well, 1 isn't very exciting. A is the only one that's really exciting. So I want my least common multiple, or my common denominator, to be a. So again, I'm not worried about the numerator right now. I'm just going to rewrite it. In my denominator, I had a over 1 and 1 over a. As we said, a was the only one that was really interesting. I need this denominator, a 1, to be an a instead. I can get that if I multiply this one by a. But I'm only allowed to multiply an expression by the number 1. So if I multiply by a in the denominator, I have to multiply by a in the numerator, because a over a is 1. So you see I'm going to get a times a over 1 over a. So a squared over a. And this is 1 over a, so now their denominators are the same, a common denominator. So I'm good. So I'm going to get 7a over a squared over a plus 1 over a. So now I'm going to combine those common denominators, because here's the rule for math. So if I have a over b plus c over b, that's the same as a plus c over b. Rewrite the denominator and combine the numerators. So the denominator they have in common is the a, and then we combine a squared plus 1. Okay, and you can see I still have 7a as my numerator. And now my denominator is one single fraction instead of a sum of fractions. So here is the numerator. Here is the denominator. I have a fraction divided by a fraction. Even though the top one doesn't look like a fraction, it is. Here you could write it that way rather. So you have a fraction divided by a fraction. You rewrite the numerator, and then you multiply by the reciprocal of the denominator. So I'm going to rewrite my numerator, 7a. I'm going to multiply by the reciprocal of this piece. So I'm going to flip it, right? A was in the denominator, it is now in the numerator. And a squared plus 1 was in the numerator of that piece. Now it's going to be in the denominator. Now this may be confusing to look at like that. So I'm going to rewrite it as 7a over 1 times a over a squared plus 1. And if you look, there's nothing we can cancel, right? We've been canceling a lot of stuff. But notice I cannot cancel an a here with an a squared, because this is a squared is added to something. So what we're going to do is we're going to multiply these fractions. Numerator times numerator over denominator times denominator. Because we have another rule that says a over b times c over d is the same as ac over bd. Just multiply across. So that is 7a squared over a squared plus 1. And that's your final answer.